Welcome to chemistry classes. In this video, we are going to discuss about surface chemistry part 2. Surface chemistry part 2. Here we have to discuss here catalysis. Catalysis. Catalyst. Catalysts are the substance which increase rate of chemical reaction. Catalysts are the substance which increase rate of chemical reaction. Okay, look here one chemical reaction, potassium chloride. On strong heating it form potassium chloride and oxygen. Okay, this chemical reaction without catalyst it need 653 to 873 Kelvin. But same chemical reaction in presence of catalyst, manganese oxide, here catalyst, in presence of catalyst it need 473 to 633. So in presence of catalyst we have to give lower temperature. Okay, so here in this chemical reaction manganese oxide act as a catalyst. This is one example for catalyst here. Okay, so catalysts are the substance which increase rate of a chemical reaction. Such type of substance called catalyst. Okay, and this process is called catalysis. The process of increasing rate of chemical reaction in presence of catalyst. Such type of phenomena, such type of process called catalysis. Clear? After that we have to understand here activity of catalyst. Okay, look here this graphical representation. This graphical representation here energy against rate of chemical reaction. Energy in y-axis we plotted energy and the x-axis we plotted here rate of a reaction. Okay, so here the first one, look here, the first one here uncatalyzed reaction. First one uncatalyzed reaction. Second one, this chemical reaction takes place in presence of catalyst. Okay, so here in presence of catalyst it need less energy. This is the energy barrier. Okay, this is energy barrier. So here reactant change to product with lower energy, with less energy barrier in presence of catalyst. Without catalyst reactant change to product and reactant should pass higher energy barrier. This is the higher energy barrier compared to this one. This is higher energy barrier. Okay, so here catalyst lower the activation energy and the reactant can change to product easily. Okay, so here you have to understand how catalyst increase rate of reaction. Catalyst lower the activation energy, then reactant can change to product very easily. Okay, look here, this is the activation energy for uncatalyzed reaction and this is activation energy for catalyzed reaction. So catalyst lower the activation energy, then reactant can change to product very easily. Clear? So here we have to understand catalyst. Okay, what is catalysis and how catalysts increase rate of a chemical reaction. Clear? And we have to understand here catalytic promoters and poisons. Promoters are the substance which enhance the activity of catalyst. Such type of substance called catalytic promoter. Example here, nitrogen reacted with hydrogen form ammonia, N2 plus 3H2 giving NH3. This is Haber process. We know this is Haber process. In Haber process, iron act as catalyst. Here molybdenum in solid state. Iron solid state, it is catalyst. Molybdenum in solid state, it enhance the activity of iron. So here molybdenum it act as promoter. Promoter mean it enhance the activity of catalyst. Clear? Next one we have to understand here poisons. Poisons mean opposite. Substance which lower the activity of catalyst. Such type of substance called poisons. Example for poisons: carbon monoxide arsenic, they lower the activity of catalyst. So here we understood promoters and poisons. Promoters are the substance, it enhances the activity of catalyst. Example, molybdenum act as promoter in Haber process. And poisons means substance, it lower the activity of catalyst. Clear? Okay, next one, we have to understand here homogeneous catalysis and heterogeneous catalysis. First one, we have to discuss here homogeneous catalysis. Homogeneous catalysis mean here reactant, product and catalyst are in same phase. All are in same phase. Such type of catalysis called homogeneous catalysis. Homogeneous catalysis mean reactant, product, catalyst all are in same phase. Same phase mean all are in gaseous state, liquid state or solid state. Okay, first example, sulfur dioxide after oxidation it forms sulfur trioxide. Here sulfur dioxide, oxygen, sulfur trioxide all are in gaseous state. Here catalyst, nitrogen oxide also gaseous state. So all are in gaseous state. Such type of catalysis called homogeneous catalysis. Another example for homogeneous catalysis, sugar after hydrolysis in presence of aqueous sulfuric acid. Sulfuric acid here aqueous state or liquid state. Okay. So hydrolysis of sugar into glucose and fructose. Okay, here sugar after hydrolysis it will change to glucose and fructose in presence of aqueous sulfuric acid. So this is also another example for homogeneous catalysis. So here aqueous state, liquid state. So all are in liquid form. Okay, so all are in same phase. So this is example for homogeneous catalysis. Last example here, hydrolysis of ester. Ester after hydrolysis it changed to carboxylic acid and alcohol in presence of aqueous sulfuric acid. This is also example for homogeneous catalysis. Homogeneous catalysis mean reactant, product and catalyst all are in same phase. Similarly, heterogeneous catalysis. Heterogeneous catalysis mean here reactant, product and catalyst are different phase, not same phase, different phase. Okay, reactant, product and catalyst are different phase. Okay, example here. Here example for heterogeneous catalysis. Example for heterogeneous catalysis, look here, Haber process. Haber process, it is example for heterogeneous catalysis. Nitrogen reacted with hydrogen form ammonia. We know nitrogen, hydrogen and ammonia all are in gaseous state, but iron it is solid state. Okay, reactant, product all are in gaseous state, but catalyst solid state. So they are in different phase. So example for heterogeneous catalysis. We learned before sulfur dioxide reacted with oxygen in presence of nitrogen monoxide. It forms sulfur trioxide. Sulfur dioxide reacted with oxygen form sulfur trioxide in presence of nitrogen monoxide in presence of NO. It is homogeneous catalysis. Sulfur dioxide, oxygen, sulfur trioxide. Okay, this chemical reaction. Here I will show you 2SO2 plus oxygen giving 2SO3. This chemical reaction takes place in presence of nitrogen monoxide. This is example for homogeneous catalysis we discussed before. Here sulfur dioxide, oxygen, sulfur trioxide, nitrogen monoxide all are in gaseous state. Reactant, product, catalyst all are in gaseous state, same phase. So this is example for homogeneous catalysis. Same chemical reaction also takes place in presence of platinum catalyst. So here sulfur dioxide, oxygen, sulfur trioxide, they are in gaseous state, but platinum, it is solid state. Okay, so here platinum used as catalyst. Now it is example for heterogeneous catalysis. Heterogeneous catalysis, because here different phase. Okay, another example for heterogeneous catalysis, another example, hydrogenation of vegetable oil. Hydrogenation of vegetable oil. Vegetable oil, after hydrogenation, it will change to ghee. Okay, vegetable oil, it is liquid state. In presence of hydrogen, it changes to ghee. Ghee means solid state. Here liquid state, gaseous state, hydrogen gaseous state, ghee solid state. Here catalyst, nickel also solid state. So they are in different phase. So example for heterogeneous catalysis. So here we discuss homogeneous catalysis and heterogeneous catalysis. Homogeneous catalysis means reactant, product, catalyst are in same phase. And heterogeneous catalysis, homogeneous catalysis means reactant, product, catalyst same phase. Heterogeneous catalysis mean opposite, reactant, product and catalyst are in different phase. And example, clear? We have to understand here intermediate compound theory. Intermediate compound theory. To understand this, look here, consider a chemical reaction. A and B reacted to form product AB. A and B reactant, it changed to product AB in presence of catalyst X. Here X acts as catalyst. This chemical reaction takes place in several steps. Here A first combined with A combined with the X form AX. Okay, first A reacted with the X form AX. Then again this AX reacted with another reactant form product AB. And here X is catalyst, it released at the end of the reaction. Okay, so here AX, it is intermediate compound. Intermediate compound means here A and B, it is reactant, AB, it is product. Before getting product, there is a short life intermediate compound. There is a intermediate compound. It is not reactant, not product. That's why we will call it is intermediate compound. Okay, so here AX, it is intermediate compound. Clear? Example for such type of chemical reaction, 2SO2 plus half O2 giving 2SO3. 2SO2 plus half O2 giving 2SO3. Okay, this chemical reaction takes place in presence of nitrogen monoxide. Nitrogen monoxide acts as catalyst. Okay, this is the chemical reaction. This chemical reaction takes place in several steps. First one, we know nitrogen monoxide, it is catalyst. It reacted with oxygen, it formed nitrogen dioxide. Second step, nitrogen dioxide again reacted with sulfur dioxide, it formed sulfur trioxide and nitrogen monoxide released here. Nitrogen monoxide here, and at the end of chemical reaction, nitrogen monoxide stays same, remains same, nothing, no change. That is catalyst. Okay, so here nitrogen monoxide reacted with oxygen. Nitrogen monoxide reacted with half O2, it formed nitrogen dioxide. Nitrogen dioxide reacted with sulfur dioxide, it changed to sulfur trioxide, and nitrogen monoxide released same without any change. Okay, so here we have to remember here catalyst, the quantity of catalyst will be same at the end of chemical reaction. Okay, also catalyst chemically same at the end of chemical reaction, there is no any chemical change for catalyst. Okay, same thing happened here. Here in the beginning it is nitrogen monoxide, at the end also it is nitrogen monoxide. It is helping to convert reactant to product very easily. That is catalyst. Okay. Also one more thing you have to understand here, the graphical representation for intermediate compound theory. Okay, so this is, we know this is uncatalyzed reaction. Uncatalyzed reaction, here it is reactant and here it is product. Reactant change to product. Without catalyst, reactant should pass higher energy barrier. This is higher energy barrier. Catalyst lower activation energy, and reactant can change to product very easily. If there is intermediate compound, this graph we will represent like this. Okay, here reactant change to an intermediate compound then change to product. Okay, so here reactant change to intermediate compound, again intermediate compound change to product. Clear? So here there is two energy barrier. This is for first chemical reaction and this is for second chemical reaction. In intermediate compound theory, there is two chemical reaction, two or more chemical reactions will be there, two or more different steps will be there. Okay, imagine if there is two steps, we will represent this type of graphical representation. This is one chemical reaction, this is another chemical reaction. So there is two peak here, you can see two peak. Okay, in intermediate compound theory, chemical reaction which involve intermediate compound, this is the graphical representation. Clear? And we have to discuss here adsorption theory. Adsorption theory. To understand adsorption theory, look here, nitrogen reacted with the hydrogen form NH3. Nitrogen and hydrogen, they are reactant, and NH3 it is product, and here iron used as catalyst. What are the different procedure? What are the different process happening here? This is we discussing here in adsorption theory. Okay, so initially here this reactants molecules will be adsorbed on the surface of iron catalyst. Okay, look here, this one, this structure represent catalyst, and A and B they are reactant. So reactants molecule will be adsorbed on the surface of iron catalyst. This is the first step. Okay, and a weak bond formed between catalyst and reactants molecule. Okay, so here first step, reactants molecule will be adsorbed on the surface of catalyst, and a weak bond formed between catalyst and reactants molecule. After that, a bond formed between reactants molecules together. Okay, in previous case, in the beginning, nitrogen and hydrogen, they are reactants, they are far away. When they adsorb on the surface of catalyst, this reactants molecules came close together. Now they are close each other and they will make a bond between each other. They will make a bond. They will make a chemical bond. Okay. After that, the bond between reactants molecules becomes stronger. Bond between reactants molecules becomes stronger and it will change to product. Bond between nitrogen and hydrogen becomes stronger and it will change to product, NH3 product. Okay, also bond between catalyst and product molecules become weak. Okay, bond between catalyst and product molecules become weak. After that, this product molecule deadsorb away from the catalyst surface. These are the different procedure happening here. Okay, so here first I told you here reactants molecules adsorb on the surface of catalyst. A weak bond formed between catalyst and reactants molecules. Then bond formed between reactants molecules. A bond formed between reactants molecules. After that, the bond between reactants molecules becomes stronger and it will change to product. At the end, product molecule will be deadsorbed. Product molecule will move away from the catalyst surface. Okay, these are mentioned over here. These are the different points we have to remember here in adsorption theory. First one, reactants molecules are adsorbed on the surface of catalyst. A weak bond formed between reactants and catalyst. Okay, after that a bond formed between reactants molecule, then this bond becomes stronger and it will change to product. At the end, at the end, the product molecule will be deadsorbed away from the surface of catalyst. Clear? This is adsorption theory, and also you can see here this figure, it represents same thing here, catalyst adsorb reactants molecule, and bond formed between reactants molecules together change to product. At the end, product molecule deadsorb away from the surface of catalyst. Clear? Okay, next one, we have to discuss here some features of catalyst. Some features of catalyst. Here, first one, we have to discuss here, amount of catalyst does not depends on the rate of chemical reaction. Only small quantity of catalyst needed. Okay, if you add much more catalyst, it do not increase rate of reaction much higher. Okay, it's mean quantity not depends, only small quantity of catalyst needed for to increase rate of chemical reaction. Similarly, here catalysts do not consumed during chemical reaction. Catalysts do not convert into product during chemical reaction. Okay, in the beginning and end, catalysts remain same, do not consumed during chemical reaction. Also, we have another features of catalyst. It is highly specific. One catalyst increase one particular chemical reaction. Okay, it do not alter another chemical reaction. It is highly specific in nature. One catalyst increase one particular chemical reaction, not another chemical reaction. Okay, and here do not shift chemical equilibrium. Catalysts do not shift chemical equilibrium. We know in reversible reaction there is chemical equilibrium. Catalysts increase rate of a chemical reaction but do not alter chemical equilibrium. Clear? So these are the different features of catalyst. Here, first one, small quantity of catalyst needed to increase a particular chemical reaction. Similarly here, catalysts do not consumed during chemical reaction. In the beginning and end, the quantity and chemically catalysts remain constant. And similarly, catalysts are highly specific in their action. One catalyst suitable for only for one particular chemical reaction. Also here, catalysts do not alter chemical equilibrium. It increase only rate of reaction, do not change chemical equilibrium. Clear? Okay, next one, we have to understand here enzymes. Enzymes are biological catalysts. Enzymes are made up of protein which increase rate of chemical reactions which takes place inside living organisms. That is enzymes. Enzymes are nitrogen containing protein. Okay, so here some example for enzymes. Here we know fermentation. Fermentation means production of alcohol. Alcohol can be produced from sugar. This chemical reaction takes place in presence of yeast. Yeast provide two enzymes, invertase and zymase. Invertase, it helps to convert sugar into glucose and fructose. Invertase, it is example for enzymes. Okay, this invertase, it increase the speed of chemical reaction. Okay, also here this is glucose and fructose. Glucose in presence of zymase, it will change to ethanol and carbon dioxide. So here invertase and zymase are example for enzymes. Invertase and zymase. Invertase, it convert sugar into glucose and fructose. Zymase, it helps to convert glucose into carbon dioxide and ethanol. This process is called fermentation. Okay, also another example for enzyme Urease. This is another example for enzyme. Urease, it helps to convert urea to ammonia and carbon dioxide. Urea, it will change to ammonia and carbon dioxide in presence of enzyme urease. So these are some examples for enzymes. Enzymes are biological catalysts. It made up of protein. It increases rate of chemical reactions which takes place inside living organisms. Clear? And we have to understand here characteristics of enzyme catalysis. Characteristics. So we have to look here different characteristics here. Enzymes are highly efficient in their activity. Enzymes are highly efficient. Even one enzyme can transfer 1 million reactant to product. One enzyme molecule can transfer 1 million reactants molecules to product per second in 1 second. That means here enzymes are highly efficient in their activity. Also here enzymes are highly specific in their activity. Enzymes are highly specific in their activity means one enzyme suitable for only one particular chemical reaction. It is not suitable. It do not increase another chemical reaction. Okay, enzymes are highly specific in their actions. Okay, next one, effect of temperature. Enzyme activity increases with increasing temperature till a particular level. Then it will decrease. Enzyme activity, rate of enzyme action increasing with the temperature till a particular level. After this particular level, enzyme activity decreases. Okay, most of the enzymes after 60 degrees Celsius, their activity decreases. Okay, we discussed enzymes are made up of protein. Protein will be denatured at higher temperature. Protein or enzymes cannot activate, enzymes cannot stabilize at a higher temperature. That's why at a high temperature above 60 degrees Celsius, enzymes are denatured. Okay, the temperature at which enzyme showing maximum activity, this temperature is called optimum temperature. Optimum temperature means temperature at which enzymes showing maximum activity. Most of the enzymes showing 30 to 35 degrees Celsius. Most of the enzyme, their optimum temperature will be between this 30 to 35 degrees Celsius. Okay, so this is the effect of temperature. Okay, enzyme activity increasing with the temperature till a particular level. Also after that particular level, enzyme activity decreases. Most of the enzyme denature around 60 or above 60 degrees Celsius. Next one here, we have to look over here, effect of pH. Enzymes are not active at a high pH or low pH. Lower pH means pH 0 to 0, 1, 2, 3. These are highly acidic. High pH means pH 12, 13, 14. These are highly basic. So here enzymes cannot work properly at a highly acidic or highly basic condition. Most of the enzymes are highly active at optimum pH. Optimum pH means 5 to 7, around neutral medium. 5 to 7 pH, most of the enzymes are highly active. Okay, also we have to understand here activators and coenzymes. Activators and coenzymes are the substance, it increase the activity of enzyme. It increase the catalytic activity of enzymes. That is activators and coenzyme. Generally activators are metal ions such as Na+, Mn2+, CO2+, okay, sodium ion, manganese ion, cobalt ion. This type of metal ions bind with the enzyme with weak bond and it increase the activity of enzyme. Okay, such type of metal ions are activators. So here these are the characteristics of enzyme. Characteristics of enzyme we discussed here. They are highly efficient. Even one molecule of enzyme can transfer 1 million reactants to product in 1 second. They are highly specific. One enzyme suitable only for one particular chemical reaction, not suitable for other chemical reaction. And here effect of temperature, and we discuss effect of pH. Optimum pH 5 to 7. Okay, and the activators and coenzyme, they increase the activity of enzyme. Generally activators are Na+. Generally activators are metal ions. Metal ions are activators. Okay, next one, we have to understand here mechanism of enzyme catalyzed reaction. Mechanism. Okay, so look here, to discuss mechanism of enzyme catalyzed reaction. Enzyme reacted with the substrate, it formed enzyme substrate complex. Enzyme reacted with the substrate means reactant. It formed enzyme substrate complex. Then this enzyme substrate complex, it will release to product and enzyme. You can see here in this figure, here enzyme. On the surface of enzyme, there is a suitable cavity, suitable state. Only particular reactant can join over here. Only particular reactant, only suitable reactant can fix with enzyme on the cavity of enzyme. After joining enzyme and substrate, it forms enzyme substrate complex. It will change to enzyme substrate complex. Okay, at the end, this enzyme substrate complex, it will release to product, it will change to product and release enzyme. Okay, this is the mechanism of enzyme catalyzed reaction. On the surface of enzyme, there is a suitable shape, suitable cavity, okay, and only suitable reactant can join on this fixed cavity. Okay, functional group such as NH2COOH and OH. Okay, functional groups such as amine, carboxylic acid, alcohol. This type of functional group act as this type of cavities. Okay, and this cavity is also called active site. Okay, active site. Only particular reactant can fix with active site of enzyme. After that, it will change to enzyme substrate complex. Enzyme substrate complex will release to product and enzyme. Okay, so enzyme chemically and quantitatively remain constant. There is no change for enzyme. Clear? So these are the things we have to discuss in this video. Rest of the part we will discuss in another video. Clear? Thank you. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.